Thank you very much for this introduction, John. Indeed, I will be brief in presenting what is GEORISK. You say that EGEC was created in 1998. I started in EGEC in 2000, 2 years after the creation. So for 20 years, I'm in the geothermal sector. And from the start, we understand that de-risking a project is a key aspect. What is important is that we know how it works, de-risking a project. So when we started GEORISK in 2018, it was not to reinvent the wheel. To say, guys, we have some best practices in some areas, we need to replicate them. But we need to have the right framework conditions and the right knowledge on how de-risking. It's what my colleague will present you. So I'm now showing you a short introduction to GEORISK project. I'll put in full screen mode, so it will be easier for you to read that. It takes some seconds, but it's coming. Indeed, it's a pity we are just meeting virtually. It would have been a pleasure for me to be with you in Northern Ireland to present and discuss after that. But here where we are. So GEORISK, it's a project supported by the European Union. It started 2 years ago and in this year. We have a consortium of around 15 partners. Sorry. With 3 different kinds of categories. We wanted to have market actors, so we have project developers, project operators. We wanted to have scientists, so we have some geological surveys and experts in geoscience to understand the underground and the issue and the risk associated with one. And we wanted to have some public entities like the Energy Agency of Greece, but also the Department of Energy from Switzerland, to understand also what are the framework conditions needed to establish a risk insurance fund. So you have in mind categories. We wanted to have full understanding of 3 kinds of actors important for such a scheme. What you can see in the coverage of our countries, we focused on some countries: France, Germany, Switzerland, and Turkey, where you have already an insurance scheme. And what we had in mind is to look at what is the evolution of the schemes according to the market maturity. More, it's mutualization of the risk. The pot is bigger, how you manage that, public-private partnership, and so on. The second aspect is to install a risk insurance in Poland, Hungary, and Greece. We see large business opportunities there. We wanted to have a scheme, and we are about to have notably one in Hungary, and we have great expectation for Greece and Poland. But it was not the end. We wanted to have lessons learned to be replicated in Europe, but also in Africa, South America, and Northern America. So you can see that the tools we are developing focusing on some countries during the operation. We want to engage with you to see what is the feasibility all over the world. We have also contact with Australia and countries in other areas. So to be brief, what was the project about? First, risk assessment. We know what is the potential risk, but we wanted anyway to be full aware about it. And we did from a white, blank page, started all the identification of the risk. From this identification, we started to rank the risk and with a risk matrix. And after, we have some tools to assess the risk. I don't go into details. We have to Guenan presenting you into details. But first, before de-risking, we need to understand the risk. If you want to know more, you can see online. You have already this GEORISK report is presenting you some categories of risk, some phase during your project development of the risk. And from that, you have some ranking. But Thomas will present you that into detail. The second aspect in the project, so we identify the risk, and after we're looking at what are the existing tools to de-risk the project. So we had a full assessment of existing tools. I mentioned already France, Germany, Netherlands. I've seen also other with notably cooperation aid in Africa or in South America. And we tried really to assess all these schemes. We had also a work on the framework condition, as I mentioned, but what are regulations needed, the law, piece of law needed if you want to establish a public scheme for de-risking project. And what was important also, it was to look at the market maturity. Indeed, you will see from the forward presentation, you cannot compare and put in the same basket Northern Ireland, where you have only few deep geothermal projects, with Paris, where you have already a lot of evidence about the reservoir, you have 40 geothermal district heating. They have a lot of lessons learned. So it's not the same tool that you need to de-risk project in a market which is mature and in a juvenile or developing market. I don't go to the details because we have a presentation from our colleagues from Greece about that, but it's just to list you here what are the existing schemes already in place. Some are successful, some are not successful. And from the assessment, we identify three categories. So the first family of highly successful schemes, and we try to understand why. And notably here, you have to have in mind when you pay for an insurance, what is important is the rate that you pay. And we had a full knowledge and assessment of the different rate according to the schemes and how they were efficient or not. So it's good lessons learned. The second family is, of course, the one which was less successful and for different reasons, maybe focusing too much only on surface exploration, but not if you are not covering the first drilling, exploration drilling, it's an issue for de-risking your project, and etc., etc. What is important and what was nice for us in our project is that we had the full understanding of Turkey. Turkey, as you know, and I hope you have followed yesterday our market report, is a hot market. You have a lot of projects under development. The World Bank engaged with Turkey for establishing specific schemes. And during our project, we launched the first call and the second call of this scheme. So we had been able to understand the view of the Turkish bank and the view of the project developer to see how successful was this scheme. And that it was, I was mentioning, so the unsuccessful funds. What we know and the key learnings is also what is important for you in Northern Ireland when you start to think about de-risking schemes is that if you want to cover only heating project, electricity project, combined heat and power, how many projects you have to size also the fund you need, what is the coverage, adopt a 60% coverage is a minimum. In some countries, France, you have 80 to 90%. So with that, you really de-risk successfully your project, and it helps the developer to develop. The premium also. Here you see we refer to a range 3 to 7%, but it's to be discussed according to the conditions, of course. Huh? I don't go to the details, you will see later, but just to tell you the first lesson learned and the key learning. Because what is really important when you look at Northern Ireland is to put Northern Ireland in this map. So you have the risk levels and the commercial readiness level. So not the technological readiness level, but the commercial readiness. What are the different market conditions, the maturity of the market? And according to that, you need to have grants, repayable grants, convertible grants, public insurance schemes, public-private partnership. We are seeing the first one in France, PPP, for de-risking project, and we hope it will be successful. Private risk insurance, we have seen them in some countries, notably with the German company Munich Re, a very interesting company, but with success and unsuccess. So fully private risk insurance, you need really to have enough project to mutualize your risk. So the aspect, key aspect for risk mitigation is, of course, the boundary condition regulations and legal. What is the basis risk transfer from the public from the developer to the public entity? The identification of the risk, and Thomas will present you the list of the risk. The funding of the risk transfer. So who is financing, and what is impressive is that you have a lot of leverage effect in such a scheme. So we see that in France, I think if we have a figure, it's 4 million euros they put only, and it was allowing to have a sustainable for 20 years. So it's not a big public contribution if you have a really successful scheme. And after all the procedural aspect, the permitting and the indicators. All that you can find, especially for the project developer, you have this tool, but for the public entity, so in charge of establishing the scheme, you have the which is also online, and you can find all the information regarding the framework condition. When we have developed that, the de-risking tools with a following assessment, we try to establish some schemes. So we focus in Hungary, Poland, and Greece. And we will see, we have a colleague from Hungary. We are waiting really good news from Hungary establishing the scheme it's a news to come, and we hope to have really this scheme in Hungary launched really soon. And what is interesting in the project is that we really try to see the simulation of a financial model, because we know that of course you will have some public, hope to see some public contribution, but you need to see and to show to public entities and authorities what is the simulation of your model for 10 years. If the model is not sustainable for 10 years, they will be reluctant to put some money in the pot. So you will see from Attila what are the conditions to have a 10 years successful of your project. And it's embracing a lot of parameters of a simulation. I don't go to detail because you have a specific presentation. And here we are also looking in the project to other countries in terms of the key countries. We mentioned Denmark, Netherlands, Belgium, Croatia, Serbia. So yeah, but today it's Northern Ireland, and we want really to see with you what can be done in Northern Ireland. So I don't go to because it's important that you go to the details of the schemes. We are really willing to work with you until end of September. So today we're in June. We have some materials available, but if you want a specific information for Marianne, let's discuss a follow-up to this webinar. Okay, I thank you for your attention, and let's learn from our experts about what are the tools for GEORISK. Thank you for your attention.
So I will try to stay in 10 minutes. So I focus here today on the GEORISK tools that we created for risk assessment. So I won't present again the GEORISK project, but I use this slide to mainly explain that our definition of risk was really from the point of view of the operator. It's the possibility of a loss for developers of geothermal projects. So it's larger than most projects who focused on risk, usually focus on environmental risk. The first, the objective of the risk assessment is to get a good understanding of the risks, and it's necessary before we can go and mitigate them. Understanding the risks, so the definition of risk assessment means essentially three things: what can go wrong, how likely is it, and what are the associated consequences. And only then we can ask what can we do about it, which is the risk mitigation, and which is the rest of the project. So we have made three tools in GEORISK. First is an online risk register, and we want it to be a reference tool for risk identification, and gives also details about potential technical mitigation options. We have online results from a risk survey about this risk register. And we also have spreadsheets which allows the operators to perform their own risk assessment. So I first introduce the risk register. So the idea was to build a risk register, like Philippe said, we wanted to start from a fresh and a blank page. So we did a very large extensive literature review, also gathering experience from past projects. And so I won't go into too much detail on how we built it, but we considered first having something a bit fancy, like this kind of bow tie event, but it turned very complex, too complex for our objective. And so instead we simplified, and now we have mainly one scenario, but they're expressed in a broad manner, so it's a bit generic, I would say. So you can check our website, georiskproject.eu, and we have a button here, the GEORISK tool. And when you click on it, you access this table. So we have various categories of risk, and you can see that we have the main category would be this one, the subsurface uncertainties, but we also have other categories which are important, and we will see that in the when I present you the survey. And so here it is, it's a list of risk, and we think it's quite exhaustive. Even so, it's quite, like I said, quite generic. And if you click on the risk, you access like a sheet of information with a more detailed description and also a list of potential technical mitigation, which would be expected from any scheme, insurance scheme. It's expected from the operator to deploy as much technical mitigation before asking for finance. So that's it for the risk register. Of course, you can have questions and we can come back. The second part was the risk survey. So the risk survey, we sent questionnaires in all the GEORISK countries that Philippe presented, and we received back more than 50 of them. And so the questionnaire was simple in principle. We had the list of risk from the risk register, and we asked for each operator, their stakeholders, how likely they think it is for their region or project, and how damaging is it, each on a scale from 1 to 4. So basically you have this kind of matrix that you can fill. And here I have the number of answers I received per each category. So I don't have time to explain the mathematical detail, but I built, let's say, a complex index to be able to rank the risks. The idea is that it's not really, it's wrong even to just sum, the risk, like this risk 4 and 1 is not the same as 1 and 4. So I don't have time to explain the details. I just compute a probability of a risk being higher than another one. And so it gives me a formal way to rank the risks. I will present you instead the results, little part of the results. Again, you can go on the website and you have all the charts. So based on these answers, we have basically a ranking based on our GEORISK countries of what are the most important risks. So I think it's important to see that overall, on average, if you take the top 10 risks here, I hope you're able to read it. You see it's all, so they're all 8 of the 10 belong to the D category, which was, the risk due to subsurface uncertainties. You see insufficient fluid information, degrading flow rate, low initial flow rate, difficult reinjection, etc. But we have also 2 risks in the top 10 lists that are not at all linked to subsurface. The first one is changes in policies, laws, tax. So it's a bit like a lack of political support, if you want. And the other one is a lack of financing. So that's interesting that for our stakeholders, it's a mix of these 2 that are the judge risk. If you use the drop-down list, you can have a detailed by country, and also we can differentiate between heat and electricity. And so, for instance, if you only look at electricity, I think it's interesting to see that we have new risks appearing in the top list. For instance, a drilling risk here, so a collapse of well casing. And also, we have the low social acceptance risk, which is now in top 5, which was not even in the top 10 list for overall. So it's basically because for heating systems, low social acceptance, it's not so much a problem, but when you go deeper, you start to have induced seismicity risk, for instance, social acceptance becomes a real issue. And now I will briefly present you the last tool we developed, which are risk assessment spreadsheets. Again, very quick. You can find it on our website, or if you want the direct link, it's on, I put it on GitHub. It's a spreadsheet. Basically, you can answer your own questionnaire for your own projects. Now we have a lot of subtleties, so you are not restricted to a 4x4 matrix. You can design your risk matrix as you want, and you can select the risk that's interesting to you. You can also rename the risk if you're not happy with our list, and you also have the possibility to do several assessments and to have charts automatically show you how your risk evolves with time. So that's just very briefly some visual we can have. And now currently I am working on a more quantitative tool. So it's just it's a draft, let's say, of the tool. It's not currently available. So not the results. The idea is that the result is not as a risk matrix on a 4x4 scale, but as an actual distribution of losses. Which is a correct way to perform a quantitative risk assessment. So with that, I conclude. We have tools which are essentially a risk register, which is a list of risk and a list of mitigation measures. We have performed a risk survey which ranked this risk according to our stakeholders. And we also have a spreadsheet which allows you to guide you through a risk assessment process. It's for us, we want it to be a robust basis for improving risk assessment practice in deep geothermal projects, which is of course the first step to a better mitigation of risks, a condition to success. And with that, I thank you for your attention. And I think we can directly go into the next speaker.
Yeah, thanks, Thomas. So next we have Attila, who is from Geothermal Express.
Yes, thank you very much. My name is Attila Kujbus, yes, and the Geothermal Express is the partner in the GEORISK project, and I would like to show you a very important result of this project. We tried to calculate the 10 years operation and financial simulation, and in this case we investigated how we could make this type of mitigation schemes sustainable. So the objective of this simulation was the calculations, how it can be sustainable. And in the process, firstly, we had to determine the legal forms, how these risk mitigation schemes could work, and what kind of main legal forms exist. And we have to determine the aimed technical issues, the risks that were mentioned before. And we had to set up the operating forms of the risk mitigation system management. Then we estimated the main assumptions of the key influencing parameters. They are the premium, the risk over, and the success rate. And naturally, we had to determine the costs of the system management. And we had to make decisions concerning the risk mitigation project types, the geological structures, the available contract types, and the hypothetical possibilities if a drilling is successful or not, or partly successful. So we had to make this kind of decisions. These are the main decision points. Inside the GEORISK project, we organized national meetings, and we issued a questionnaire for the key stakeholders. And from the reply, naturally we analyzed the replies, and we in this case we made the decisions. You can see here the main Hungarian decisions. Naturally, in every country, this type of decisions are different. So we wanted to deal with all deep short-term projects. Short-term means that mainly focuses on the exploration phase, not for the operation phase. We have sandstone and fracture carbonates in Hungary. We wish to deal with both of them. As a contract type, we wish to use the grant, and in the hypothetical possibilities, we calculated with successful or failed projects. It is more simple for us to determine the final result. And there are a lot of scheme structures. We analyzed all of them, and we determined that for the Hungarian natural background, French structure means more or less the best. And concerning the sustainability, we have to make a decision. We had to say that at this present market, geothermal and renewable energy market position, the sustainability is too costly for the projects. The premium of the sustainable level is rather high. Therefore, we would like to use the scheme mixed with the national support system. This is the proposed operating chart. The Ministry of Innovation and Technology established a risk management fund and risk management systems secretariat. The technical committee makes the strategic decisions, and experts support the secretariat to determine if a project is successful or not. So professional expertise is needed. And the secretariat is in connection with the public or private developers, the projects. And if the project is unsuccessful, naturally they pay the reimbursement for the project developer, and the project developer's fees pays the fees for the fund. So this is a fairly simple system. It is nearly the same in France now. Naturally, we had to plan for the next 10 years what kind of projects we expect in the next 10 years. So we selected about 30 potential projects for the next 10 years, deep, very deep and shallower projects. And we calculated with 2 years of exploration phase. You can see porous and karstic fractured reservoirs, and you can see all kind of sizes exist in the next 10 years. So we estimated what will be in the next 10 years. And this is the key information. These are the key information for the simulation. So there are 10 years. We calculated 30 projects, so 3 new projects every year. And as the project exploration is about 2 years, so pending projects are 3, 6, or 7 every year, pending projects. And naturally, from the second years, we calculated with closed projects. We calculated with 10% success rate, it means that from 30 projects, 3 projects will be unsuccessful. So we had to calculate 3 payment for unsuccessful projects. The risk over we calculated 75%. So we paid, we planned to pay the 75% of the exploration phase for 3 projects. And we calculated with income. The main income is the 10 million euro that we planned from the fund, from the ministry. And every year we calculated with the premium of the 3, 6 or 7 pending projects. And naturally, we calculated with expenses the cost of the technical committee and the cost of the experts. We calculated all of them. And in this case, we could calculate total asset balance. And you can see that in the case of 10% premium, 75% of risk over, and 90% of success rate, this system can be sustainable. Naturally, the Greek and Polish partners in the other 2 focus countries made about the same calculations. However, every year, every country, we have to see the natural background and the legal background. So the systems are and the whole calculation method is not all the same everywhere. In Greek, for example, the risk is different in the continental area and in the islands. Therefore, they calculated, you can see they calculated 90% and 75% success rate, and 67 and 50. So you can see that the system is very sensitive for the success rate. In case of 90%, it can be sustainable, but with 75%, 67 and 50% success rate, it is unsuccessful, unsustainable. So it needs some kind of or national or other community support, but they can exactly calculate how many support it is needed. So it needs, it is a very effective calculation for an effective support. The Polish colleagues calculated different percentage of premium, 10, 8, 6, and 4%, and the risk over 75, 70%. So you can see that in this case, the system can be maintained, can be can retain on a sustainable phase. However, it needs from the 6-7 years, it needs some kind of support as well. So it is a method to calculate that at this market phase, geothermal or renewable energy market phase, how much and what kind of support the system is needed, or how level of premium, presently about 10%, is needed in order to retain it on sustainable level. Some words about the summary. So we analyzed the key parameters, the premium, risk over, and success rate, and we determined that there are a lot of similarities in the target countries. So we believe that this method, this calculating system, can be used in in all countries as well. However, the legal and the natural environment can be taken in consideration. And we have some recommendations. We say that this risk mitigation system is a very effective way to support the geothermal sector. And we propose to widen it in Europe. During the planning of a new risk mitigation system, it is important to take into consideration the long experience of the former and existing systems. We analyzed mainly the French and the Dutch system, but there are a lot of them, and it is very important to analyze them. And if in a country they want to establish a new system, perhaps may not the most practical way to establish a new one. They can analyze if to join an operating system can be useful, a better solution. In order to push the overhead costs and the premium to the lowest level, establishing a larger and larger international systems seems to be more and more feasible. And we say that a European geothermal risk mitigation system should be considered. Thank you very much for your attention.
Hello, everybody. Greetings from Greece. I'm Spyros Karytsas from CRES, the Center of Renewable Energy Sources of Greece. Just one moment to share my screen. And okay, excuse me one moment to find the file. Sorry. Okay. 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 Can you see my screen?
Mm-hmm.
Fine. Okay. So I'll be talking about the activities that the GEORISK project has been conducting concerning the capacity building. I'll try to be short in time and not talk again about the issues that have been mentioned from previously from our partners. So first of all, just to remind you that the aim of these activities is to have a replication of the best practices that have been identified in the 5 key countries, talking about Turkey, Germany, Switzerland, the Netherlands, France, as well as some best practices around Europe and around the world. And first of all, to apply these best practices in the 3 target countries of the GEORISK project, Poland, Hungary, and Greece, in addition to some other European countries, Denmark, Belgium, Croatia, Serbia, and Slovenia. These extra countries are not partners in the GEORISK project, but they are in the general target countries that the project aims. And moreover, to also try to apply these best practices in 4 third countries, meaning countries outside Europe, namely Chile, Mexico, Kenya, and Canada. In order to do so, the first step is to analyze the market conditions of the targeted countries, to create connections and communications with the decision and policy makers, and to work on building on the capacity building. The final target is to establish or adapt risk mitigation schemes, if possible, 3 years after the GEORISK project has been completed. So an important step of the capacity building, which is based on the results coming from the GEORISK projects, have to do with the importance of identifying the criteria in order to establish a risk mitigation scheme, either public, or private, or a public-private cooperation. The first criterion has to do with the basis on which the risk mitigation scheme will be based on. The second criteria has to do with the relevant risks. The third criterion has to do with the financial aspects. The fourth criterion has to do with the whole process of the granting aid. And the fifth criterion has to do with evaluating the performance of the risk mitigation scheme. Going in more details on these 5 criteria, we could say that the legal conditions should justify an engagement in the development of a risk mitigation scheme. Usually such legal frameworks define the funding sources, the mechanisms of the risk mitigation schemes, their form, their scope, their duration, and their structure. Within the GEORISK project, we have categorized the public, the private, and the PPP schemes. When talking about public schemes, the legal basis, which could be an act or a decree, could be based on an energy act or an environmental act. When we are talking about the private schemes, the legal and regulatory framework is usually set through articles of association or chapters of the commercial entities that apply this risk mitigation scheme. When talking about the public-private partnerships, we could say that, for example, we have publicly held banks or insurance companies that are mandated by the government or other national agencies to provide low interest loans or low guarantees. So in this context, we have a regulatory framework that combines characteristics of both the public and private sectors. Now, going to the main actions that should be engaged in the context of establishing a risk mitigation scheme, and when talking about the legal and regulatory conditions, we could say that the first task is to carry out a full inventory of the energy policy framework in the country, to see which of these acts or laws have impact on the development of a geothermal project, and additionally on the establishment of a risk mitigation scheme. And of course, this inventory aims to highlight the barriers of geothermal deployment when talking about the regulatory and policy context. The second task should be to evaluate the geothermal knowledge and the available geothermal data on the local geothermal resources, and to be more precise, to see if there is availability of such geothermal data. The third task has to do with the establishment of a list of existing decision makers and policy makers on a local, regional, or national governmental level, in order to contact them and communicate with them to discuss the introduction and development of a risk mitigation scheme for the geothermal sector. Now, moving on and going to the identification of the risks, our partner Thomas Guenan has already described some relevant issues in more detail. In any case, we could say that the engagement of the institutions, either public or private, depends on the risk profile of the projects. Historically, it is at the earliest stages of the development where the geological risk is significant and of biggest consequence. And in that cases, usually the risks are transferred to the public institutions. Private insurance solutions are usually not available in these steps of the development, while when available, they might be unattractive and unlikely to be economically justifiable for commercial operation. Moreover, concerning the risks, we could say that the geological risks due to reservoir uncertainties are one of the main drivers for the engagement of public authorities in these schemes. So public institutions have to make available a wide range of support mechanisms which should be tailored to meet the specific needs for each development phase and of course for the conditions that each different country or even region might face. Now, an important issue that we should mention is to have a long-term vision and to have a continuity of the support mechanisms in order to be able to establish a sustainable geothermal market. And in this context, we could mention the main actions that should be performed in order to deal with the risks. The GEORISK project has worked a lot on these aspects in order to study the risks per country or per region. And some of these tools have been mentioned before. Within the GEORISK project, we have the online risk register. We have developed the risk assessment results for the countries of the project as a general guide. And there is also available a spreadsheet that can allow new countries or new regions to make a risk assessment dedicated to their specific deep geothermal project. Moving on and talking about the funding of the risk transfer schemes, we should mention that such schemes rely on a clear capital and financial structure in order to guarantee a sustainable and reliable support for the development of the geothermal activities. It is important to have a legal basis that defines where the funding comes from, the source of the funding, while it has been identified that possible public funding sources may be revenues from single public institutions, joint budget between several public institutions, a surcharge of the high voltage transmission grid that will be feeding the risk mitigation scheme, or a levy on manufacture, production, and import, again feeding the risk mitigation scheme. Some additional results coming from GEORISK that are quite important when referring to the funding of the risk mitigation scheme have to do with the conclusions of the worldwide inventory of 23 risk mitigation schemes that have been existing between 1980 and 2020. The main recommendations that can be proposed based on the results of this inventory have to do, first of all, that the coverage should include electricity, heat, and cogeneration. The risk mitigation scheme could be based on the French SAF environment as well on the Dutch scheme. A third recommendation has to do with the fact that the coverage should be improved. For example, based on the Turkish risk mitigation scheme, meaning that there should be an increase of the guarantee rates in regions with poor geological knowledge. Another recommendation has to do with the adoption of a reimbursement rate that would be at least 60%, and it would be better to be between 80 and 90%. While the last recommendation has to do with the level of the insurance premium that should be in a range between 3 and 10% in order to encourage a great number of participants in the risk mitigation scheme. Now, when going to the main actions that should be engaged, the first action is to carry out an inventory of the potential geothermal plants as presented before by our partner Attila. And the second task is to plan the financial aspects of the risk mitigation scheme on a 10-year period, again, as presented in more detail before by Attila. Moving on to the procedural aspects, we should say that in order to have an efficient risk mitigation scheme, it is important to have a clear definition of what is expected from the applicant, meaning that we should know how are the requests processed and by whom, and how is the contractual relationship managed in case it is awarded. The procedural aspects have to be clear, simple, streamlined, and adapted to the purpose of the risk mitigation scheme. The main actions to be performed in relation to the procedural aspects have to do with planning the management of the fund itself and to draft the involved stakeholders in the process. Here, it is the model of the operation of the Hungarian risk mitigation scheme is presented, which was already presented before by Attila when talking about the Hungarian scheme. And finally, the final step has to do with evaluating the performance of the risk mitigation scheme through key performance indicators, which could of course vary depending on when talking about a public scheme or when talking about a private scheme. Some common metrics could include the number of applications submitted, the percentage of successful applications, the volume of aid awarded, the evolution of installed capacity, some socioeconomic criteria, such as the creation of long-term employment, the increase of public subsurface data, the creation of local skilled workforce, etc. Finally, the main actions to be engaged when talking about the performance indicators is, first of all, to define the indicators, the key indicators that are appropriate for each risk mitigation scheme depending on its characteristics. And the following step is to define how these key indicators should be monitored, again, depending on the specific characteristics of each risk mitigation scheme. This was my presentation concerning the capacity building of the GEORISK, combined with several important results of the project. Thank you very much.